All right, let's dive right in. We're talking about AI and CI/CD, the engine that powers pretty much all modern software development. But what if that engine could actually think for itself? We're going to explore how AI is turning this whole process from, let's say, a basic assembly line into a super intelligent, self-improving software factory.
But before we get into the cool AI stuff, let's start with a question I bet every single developer has screamed into their monitor at some point. With all this amazing automation we've built, why does everything still break so often? It's a super common frustration, and honestly, it points to a much deeper problem with how we've been doing things.
And yeah, this isn't just a feeling, it's a fact. The data is pretty staggering. 45% of businesses are dealing with CI/CD pipeline failures every single week. That is almost half. It's the clearest sign you could ask for that just having automation isn't enough. We need something smarter.
Okay, so here's our game plan. We'll kick things off with something I'm calling the automation paradox. Then, we'll dive into the AI upgrade and see what a smarter pipeline looks like. We'll also get real about the challenges on the horizon, and finally, we'll look at the autonomous future this is all leading to.
All right, Section 1, the AI upgrade. This is all about moving from being reactive to proactive. You see, the paradox is this. We've automated so much, but our automation is, well, kind of dumb. It just follows a script, it waits for something to break, and then it tells us. AI flips that completely. It's about getting ahead of the problems, preventing them before they ever happen.
And here's the difference in a nutshell. Traditional automation is reactive. It follows a fixed set of rules, and if something unexpected happens, boom, it breaks. It's brittle. But intelligent, AI-powered automation is proactive. It doesn't just follow a script, it learns and adapts. It becomes resilient, which is exactly what you need to handle today's complex software.
So, what does this actually look like in the real world? Let's walk through the pipeline stage by stage and see exactly where and how AI gets to work. This is AI in action.
First up, code review. This is your first line of defense, right? The whole idea here is to catch problems as early as possible, what we call shifting left. And instead of relying purely on a human teammate to spot every little thing, AI can act like an instant automated expert reviewer. And the benefits here are huge. The AI can perform super smart analysis for bugs and security holes. It can automatically enforce your team's coding standards. And maybe most importantly, it gives developers instant feedback. No more waiting around. The bottom line? Finding and fixing stuff this early can slash your downstream costs by a whopping 20 to 30%. Okay, on to the next stage, testing and QA. And let's be honest, this is often the biggest bottleneck in the whole process. It's that part where everyone is just waiting for those long test suites to finish running. Well, AI attacks this problem in 3 really smart ways. First, there's predictive test selection. The AI looks at your code change and only runs the most relevant tests, not the whole shebang. Second, it can automatically generate new tests, catching weird edge cases a human might miss. And third, and this is super cool, it can create self-healing tests that fix themselves when the UI changes. That saves so much time on maintenance. And the result of all this? It's pretty dramatic. Just that first step, predictive test selection, can slash your test execution time by 30 to 40%. Think about that. That's a massive speed up in getting feedback to your developers. All right, next up, the build and pipeline optimization. This is where all the code gets compiled and packaged up. And the 2 big headaches here are 1, builds that just randomly fail, and 2, burning through a ton of money on cloud resources. AI tackles both of these. By looking at all your past builds, it can actually predict if a new one is likely to fail, before you even waste time and resources running it. It can also be way smarter about allocating cloud resources. The end result is you get about 25% fewer failed builds, and you save a good 15% on your cloud bill. Win-win.
And now for the really high-stakes part. Deployment. This is it. We're pushing the new code out to actual users. The absolute #1 goal here is to do it safely, without breaking things for your customers. And AI is a total game changer for taking the guesswork out of it.
And I mean, the impact is just massive. We're talking about a potential 90% reduction in customer-facing outages. How? By watching the system's performance in real time as the new code goes out. If the AI spots trouble, it can automatically trigger a rollback, pulling the bad code back before most users even notice there was a problem. That's huge. So, the software is live, but the job's not done. This brings us to the final piece of the puzzle, monitoring and self-healing, or what the industry calls AIOps.
This is where we go way beyond just watching dashboards. This is where the system learns to take care of itself.
And this is truly a game changer. The AI can spot weird behavior, anomalies, long before they set off any alarms. It can instantly figure out the root cause of a failure, so no more all-night debugging sessions. And in some cases, it can even heal itself by restarting a service or applying a known fix automatically. All of this leads to an insane reduction in recovery time, up to 80% faster.
So this all sounds pretty incredible, right? But it's time for a quick reality check. Because implementing all this stuff isn't exactly plug and play. AI is incredibly powerful for sure, but it's not magic.
So, let's just ask the question straight up. Is this transition easy? And the short answer is no, not really. There are some very real hurdles that every organization is going to face.
Here are the 4 big ones you'll run into. First, data quality. Your AI is only as smart as the data it learns from, so garbage in, garbage out. Second, you've got skill gaps. Your teams need to learn new tricks. Third is the famous black box problem. You need to be able to understand why the AI is making certain decisions. You can't just blindly trust it. And finally, security. AI-generated code still needs a human review. But the main takeaway here is that none of these are showstoppers. For every challenge, there's a solid strategy to manage it.
So, once we navigate those challenges, where does this all lead? What's the end game here? Let's take a look at the big picture, the autonomous future.
The ultimate goal, the holy grail, is what we call autonomous DevOps. The idea is to graduate from pipelines that we have to constantly babysit to systems that are so intelligent they can pretty much manage themselves.
And this really says it all. The future we're moving toward is one with pipelines that are self-managing, self-optimizing, and self-healing. Think about that. They don't just follow orders anymore. They think, they learn, and they get better all on their own.
And that leaves us with one final, really big question to think about. When our systems can finally fix themselves and we free up all of our brilliant engineers from just keeping the lights on, what are we going to build next? What incredible things become possible then?